My name is Bad, and I'm working at Mimo. So today we're going to talk about DeFi governance with Mimo. So today we're going through different things. First, I'm going to introduce you the platform, so what is Mimo. Then we're going to go a bit deeper, talking about the vault and what we can do with that. And then we're going to switch and focus on the governance token and how we manage a cross-chain gov token. And at the end, we're going to focus on the liquidity and how we manage the cross-chain stablecoin. So what is Mimo? Mimo is a DeFi lending platform used to borrow some stablecoin against collateral. So what does that mean? Is that you connect to the platform, you deposit some collateral, and you mint some stablecoin. This stablecoin is an algorithmic euro stable token, and as I said, it's again collaterals. Today, the platform is supporting 3 types of collaterals. The first one is wrapped-BTC, the second one is wrapped-ETH, and the third one is USDC. Of course, we're using also a decentralized price feed. And then, to finish, we're also multi-chain, not only on Ethereum. So let's talk about vault management. So first, what is a vault? A vault is the main interface for a user to interact with the platform. After that, the user, when it's got connected to the platform, it can use different types of transactions. So it can deposit in order, of course, to mint some stablecoin. So here is the transaction workflow. So first, the transaction is made of an approve of collateral deposit. Then there is the deposit. So what we check here is that the allowance is at least equal or above to the collateral that the user is trying to deposit. And if it's the case, then the transaction can go through, and we can then transfer the collateral and update the vault balance. Then, once the user has deposited the collateral, there is the borrowing. So the borrowing is straightforward, but there is one thing you have to understand, which is the health factor. So the health factor is an indicator to see if the vault is healthy or not healthy. So what is a healthy vault then? A healthy vault is when the value of the collateral is above the MCR. And if it's the case here, then it's all good. So to just recap the borrowing transaction, first, we have to check all the rates, to update all the rates and check all the depth indexes. So we have to make sure that everything is up to date, rates and depth. After that, we can add the fees to the borrowing balance. We calculate the fees, we do the check, and then if everything goes right, then we update the vault, the borrowing vault, and we can mint the stablecoin, and we can transfer the stablecoin to the user. After some time, when the user has minted some stablecoin, it's time to pay back the debt. So what happened here? For the repay transaction, same as the previous one, we have to update the rates and the debt indexes. We have to check the balance, so we have to make sure that the user has the exact amount of what he's trying to repay. And if it's the case, then we can burn the power. We can burn the stablecoin, and we can update the vault. As simple as that. The last transaction is the withdrawing. So once the user has deposited some collateral, once he has borrowing some powers and then repaying them, it's time to withdraw and to get back the collateral. So what happened here? Basically, we need to do 2 checks. The first one is making sure that what the user is trying to get back is actually in the vault. And the second one, we have to make sure that once the withdrawal happened, the vault is still healthy, right? So the first step, as usual, update the rate and depth indexes, check that the user collateral balance, as I said, and after that, we can transfer all the collateral to the user. Liquidation. So we also have a liquidation, and you have to know that the liquidation is open to anyone, as long as the vault is open to that. So, for example, here, as usual, starting with depth, update the depth and the rate, and after that, we check the health factor. So the health factor here, for the liquidation, is not based on the MCR, but is based on the liquidation ratio. So we make sure that the vault can be actually liquidated. So if it's the case, we do a second check. The second check is the balance of the collateral equal or bigger to the total debt borrowed by the user? If it's the case, we can charge the liquidation fee, we can burn the bar, we can update the balance vault, and then we can transfer the collateral to the user. But if it's not the case, if the collateral value is under the value of the debt, in this case, we have an insurance fund just here. And what does this insurance fund do is simpler. So it's supposed to burn the missing par from the liquidation. So we burn some par, and after that, we go to the same price, the same level of balance between the collateral and the debt, and at this time, we can let the flow continue with the normal path. Okay, so now let's talk about the governance token. As a lot of DeFi platforms, we also have our own Gov token. At first, we were on Ethereum, and we had a very simple architecture for distributing the incentive based on the MIMO distributor. So what is the MIMO distributor? MIMO distributor is a smart contract that can mint the token and distribute that to those demand and supply miners. So what are they? The demand miners are made to distribute the incentive to users that are actually providing liquidity into pools using a LP tokens mechanism. And the supply miners, they are made to incentivize people minting stablecoin against some collateral. So here, we have to understand that there is one supply miner deployed for every collateral we have, and one demand miner deployed for every pool that we are incentivizing. But then we wanted to move to a new chain, so we had to think about it. And we came with an idea of just duplicating what we had. So okay, let's take a new token, a new MIMO distributor, and just deploy that in the new chain. It's working fine, but the issue is that users that are receiving tokens on the new chain couldn't switch between chains pretty easily. So we had to think about a better model, a better approach. So the multi-minting distribution approach was good at first, but then very not user-friendly. So we switched to the multi-allocation approach. So what is it? Basically, it's the same architecture that we have on Ethereum, but instead of having a smart contract that is actually minting some tokens, what we did is just to define an allocation. So we take some Gov tokens, we send them into the new chain, and we use that as a, let's say, allocation for chain allocation. So it's nice, it's working properly, but then we had few things that were not super convenient for us. So first, the user, even if there is a bridge, it's not very efficient for them. The second part is the flexibility. What happens if we want to change the allocation? So if you want to increase the allocation, or if you want to decrease the allocation? It's kind of tricky to manage that, so we thought that it was better to find something else. And we came up this architecture. So we keep the MIMO distributor. We also keep the demand and supply miners. But what we have between, it's a new layer that we called chain distributors. So here, to just give you an example, oops. Oops, sorry. So here, like the previous example, the MIMO distributor is sending some tokens to the Ethereum distributor. And then this distributor is sending tokens to those miners. So the configuration is simple. Here, it's just about setting the shares. So here, let's say you have 50% for Ethereum, then every time the smart contract is minting some token, 50% of them is going there. And here, we have also a configuration of shares. And all of those tokens are going to be distributed into those different miners. But on the other side, you have the new chain distributor. And it's actually working the same as the Ethereum distributor, but it's leveraging the bridge of the chain to reach those miners deployed on the other chain. So basically, what we have today is this. A MIMO distributor, a layer of chain distributor, and then a layer of miners here. So what is it allowing us? It's simple. We can choose the incentive between chains pretty easily. So the flexibility that we were lacking before, we have it now. So for example, if we want to incentivize 50% for Ethereum, 20% for Polygon, and the rest for Fantom, that's pretty easy. We just need to create a new proposal, let the people vote, let the community vote, and after that we can just change the config. And here, all of those bridges are just pass through. Here, Polygon are sending to the miners. Here, Fantom distributor are sending to the miners here. So the architecture we have today allows us to have a cross-chain Gov token with something very interesting for us, a centralized configuration on Ethereum. Now, let's talk about the liquidity. So what you can see here is the Ethereum MIMO protocol deployed on Ethereum. Here is the MIMO protocol deployed on Fantom. Every one of them are actually minting native power. So there is Ethereum power and there is Fantom power. We have decided here to bridge only the power token, the power from Ethereum, to bridge it into Fantom, to have a pool, a stable pool here, allowing the users to also switch between chains using the pool. So this is what we're doing today, and it's really scalable because we can do that on any chain. We just need to bridge the Ethereum power into this new chain, and then creating a pool, creating a stable pool, and then it's working fine. Okay, so my name is Badredine Yayaten. I'm the CTO of MIMO, and thank you for having me today. Thank you for your time. And if you have any question, please let me know. Thank you.
Hello, thank you for your presentation.
Thank you.
And there is a question about bridges, of course. So you have your stablecoin sitting on different chains. Original is Ethereum, right? And the wrapped versions on other chains. And what happened with the system if bridges failed? And who are protecting those bridges from being hacked?
Your question is, what happened if the bridge failed at the time of the transaction, let's say, to switch?
No, in general, it's actually holding a lot of funds, right? And what will happen with the whole system, the whole architecture, if there is only one bridge is failed?
So if one bridge failed, so first the issue is on one chain, right? And on this chain, if the bridge failed, then it depends on the failure. Is it a hack? Is it a wrong architecture? Depending on the issue, we have like different solutions. But yeah, the bridges, they have some funds, but in terms of issue, yeah, it depends on what kind of issue. But if the bridge disappears, then yeah, we have to find another bridge, and we have to fix that.
No, the question is, if your bridge hacked and money just withdrawn to somewhere, and it happened, for example, on Fantom, will it influence the Ethereum smart contracts and liquidity and financial operations there?
So because because we have PARs native on every chain, so first, the way the PAR is working is kind of independent from the bridge. The bridge is allowing the users just to switch between chain. So that being said, if the bridge has been hacked, in this case, yes, we have a big issue, but there is more than one bridge, and we can always like configure that to switch bridges and manage the lost funds. So we can work on that. But yeah, basically, because the PAR tokens, they are completely independent from chains to chains, then we don't have a big impact on the price.
But they are not, they are connected actually. You mentioned that there is a pool, which is like wrapped token and the native token, right?
Yes.
So if there is an issue within one bridge, it is not influencing the Ethereum liquidity and the Ethereum price, because there is only one way, as far as I understand, the pool.
Yeah, but the pool is a stable coin, a stable pool. Yeah. So it's going to be, if it's not close to 1-for-1, so yeah, the price is not really here, that is...
So the stable coin, if the bridge is hacked, you have more wrapped stable coin, right? So this price can go down, and because people will think that it is arbitrage opportunity, the prices on another chains can also fail, right?
Okay, can you repeat just the last part of your question?
I mean, if you have DPEG for your wrapped assets on one chain, it can actually influence the DPEG on another chains, right?
Mm. Yeah, so if the bridge is hacked, then we have like some wrap tokens on the new chain that are kind of faulty. Yeah, I'm not sure about the impact, but that's yeah, that's a good question. Thank you for asking that. Not sure I can answer now.
Yeah, we're just designing multi-chain solutions, and every time you're working with, you understand that you have a single point of failure, which is oracles. If you're working with oracles and just moving data from one chain to another, or bridges. And this is why I'm asking about how to make a protection from bridge attacks. Anyone else?
Yes.
Thank you.
Thank you.
Anyone else?
You've got one up the back there. Up the back.
Thank you for your presentation.
Thank you.
So I have two questions. The first one is about the bridge. Is it a centralized bridge that you run on your side, or will it be more decentralized?
Yeah, usually we go with the biggest bridge used for the chains and the one that are permitted by the chain itself.
Okay. And for Fantom, your website is not live for Fantom, I believe.
Yeah, no, it's not.
Is it coming soon? Or?
Yeah, it's coming. We're working on it.
All right. Thank you.
Thank you.